There's a little handout exercise. Guess what? You get to participate after lunch here, keep you awake. All right. So Matt asked me to talk a little bit about AI and robotics and manufacturing. And so I wanted to take this opportunity to kind of look at the topic from more of a strategic, big picture perspective at first. So give you the lay of the land, what's happening in robotics right now, but then also hopefully some insights that are more actionable in the immediate term. And so right here, there's a couple of videos. Like if you've spent any time online or on social media, you probably have seen robots doing all kinds of crazy things coming up on your feeds, right? So kung fu and parkour and all kinds of amazing things that robots are supposed to be able to do nowadays. And these are a couple of headlines from startup companies. So a lot of this hype is coming out of the Bay Area, right? That's where hype comes from. And um, there are very well-funded startup companies with staggering valuations that are being funded by really big name venture capital companies right now. So these are in the billions of dollars. These companies are maybe just a couple of years old. And they're demonstrating robots doing tasks that are completely unimaginable only 2 years ago. So this is, generating a lot of hype, obviously. And if the hype is true, like what these robots can actually do comes to pass, then it creates kind of a Darwinian moment for companies, not just in manufacturing, but across all of the economy, because it changes how to think about work in general. And if Darwin taught us anything, it's that it's not necessarily the smartest or the strongest species that survives, but it's the species that's best able to adapt to its changing environment. And so that goes for companies as well. And, basically, if all of this hype is true, then you need to understand the environment because the alternative is extinction, right? And I did actually hear that they are cloning the dodo and bringing it back, but you don't want to be that company, right? So um, I'm Joe Cole. I'm the co-founder and CEO of Rose City Robotics. We're a 2-year-old startup, and we focus on computer vision solutions for finding defects in manufacturing. So if you're a quality control manager or VP and you're going to bed at night worried that last minute production run that has to ship out first thing in the morning is going to come out and reach your customer's hands without problems, defects in the product, then our systems will help create a consistent, measurable metric that you can see that there's quality going out your door every day. All right, so back to the big picture. This is Jensen Huang, if you don't recognize him. He's the CEO of NVIDIA, the biggest company in the entire world. And if you've heard him speak at all at pretty much any event in the last couple of years, CES, or pretty much any time he speaks, he's always really pushing robotics. And he's promising really great things. This robot on my right, your left, is from Agility. It's called Digit. And this is the first commercially deployed humanoid form factor general purpose robot. I think that Amazon has some of them. It basically moves totes around in facilities. So they're really, NVIDIA is creating the infrastructure to train robots and AI to do all these amazing tasks. And so I think that one of the things that I hear a lot from people when they hear this, that robots, able to do pretty much anything in an environment, is there's a feeling of unease that comes with that, right? Because the world is changing really fast. And, if you heard all morning about AI and that's changing white collar work, well, robotics will also take that same technology and potentially change blue collar work as well. So what is there going to be left for humans to do? And I think this captured, Bryce Howard was talking about Black Mirror episode that she starred in. If you're familiar with Black Mirror, it's all about how technology is, taking away from our humanity. And so it's a legitimate concern that we need to understand how this impacts workers, but we need to be clear-eyed about what is hype and what is reality. And so I'm here to tell you that the reality of general purpose robotics right now today is very different from what you might see online. This is a project that I was working on for a customer, and they wanted to create a marketing demo of this is the Unitree humanoid robot, and this is the same one that you see doing all the kung fu and crazy stuff online. They wanted the robot to pick up a grocery bag and put it into the trunk of a car. And so we did that. It was a 2-month project. It was a lot of fun to work on. We were successfully able to program the robot to do this task. But also, the day before the demo was supposed to run, the hand fell off the robot. And so I spent that night staying up and soldering these tiny wires together to try to reattach the hand back onto the robot. And then, of course, we had also shipped the robot to the event. And in shipping, it got jostled around. And so the camera connection was really unstable. And I had to, the morning of the demo, rewire camera wires to try to get a stable connection to that camera. And so the reality is, at least at this moment, general purpose robotics is not ready to deploy into manufacturing environments in general, with the exception of maybe those agility robots that I mentioned before. So there's this sort of gap between what's technically possible and what is feasible economically and reliably to put into an environment. And so you might ask yourself, why do I even care then, right? If the sci-fi future that we're being promised, Jetsons and all that, is not real, and the reality is dingier and more complicated than that, why should I care? And the reason is because this is what is coming in the near-term future, right? So we understand how to make robots do these tasks, and we should be preparing ourselves now for the day when it does become an impact in a real manufacturing environment. And so the next couple of slides, I just want to talk about what is the change in technology that's enabling robots to do things that weren't possible before. So this video is this is from a research paper that was published by a group out of Stanford University, and they created this robot, and it's able to do a pretty amazing task, right? It picks up a dirty dish, it navigates to the kitchen sink, it turns on the faucet, rinses out the pan, and puts it in a drying rack. But what's really amazing, and you might not see it at first blush when you look at this video, is that the hardware components that they used to build this robot are really complete junk, compared to industrial robot arms that are typically in a manufacturing environment. So those industrial arms would have positional to be able to repeat the exact same path and put the end effector, the manipulator, on the end of the arm in the exact same position within the width, half the width of a sheet of paper, and do it thousands of times exactly the same way. These robot arms, if you look at the research paper, they actually measured it. So they programmed the arm to follow the same exact path and put a dot on a sheet of paper. And so it was supposed to be in the same position every time. The error that was from these arms was over 12 centimeters. So that's like 4 inches. And so, I mean, look at what, well, if we can play it again. I don't know if we can play it again, but, oh, here it goes. So, I mean, you can't pick up a pan if your positional accuracy at the end effector is 4 inches. It'd be all over the place. So how did they actually make these really low-cost components do that? Well, if you look on the end of the arms, there's also a camera, and that camera is giving visual feedback and providing a source for error correction in real time on the fly. And so the computation that's available in that laptop on the robot is able to correct the positional inaccuracy of these low-cost arms. So that's one piece, right? We can use lower cost hardware. We can use software to compensate for that difference. And the other thing is, well, I'm curious to ask the room, like, how many of you use large language models, AI, in your daily workflow? Is anybody? Okay. I mean, it's starting to be more and more popular. I personally use it pretty much every day, and I've heard it said that, the awe that you might feel for AI is directly correlated to how much you use AI in your daily life to write software code, which is what exactly I do. Not everybody's in that situation, but I also used AI to build this entire PowerPoint presentation from scratch. So, I mean, it is really changing white collar workflows dramatically. Um, and that same exact technology that's behind large language models is called transformer neural networks. The same exact technology can also be used for robotics, because what transformers do is they take in a stream of numbers, a sequence of numbers as inputs, and those numbers could represent language tokens, but they don't have to. They could be something else. And then it encodes the sequence of numbers into some kind of abstract concept space. So it learns abstract concepts from the input data. And then it predicts the most likely output sequence of numbers, which in the case of large language models is also language tokens. But you can do the exact same thing using the exact same technology, but instead of language, you can use video streams as your input and motor control signals as your output. They're both just sequences of numbers. And so we already know, all the power of large language models is directly transferable to what we can do with AI in other domains. And so why do we have large language models everywhere, but not robots everywhere? And the difference is there's what I'm calling the data gap, right? For large language models, we scraped the entire internet for pretty much everything that was ever written by a human to train a model big enough to learn those sequences. There's no equivalent data set for robotics. And those couple of startup companies that I mentioned on that first slide, this is exactly what they're working on, is generating these data sets that you would need to train a transformer neural network to do arbitrary tasks. But we've got a long way to go to build up the data that's needed and make this a reality. And so that's kind of the big picture perspective. Now I want to narrow in a little bit and just talk about automation in the manufacturing process. And so automation's been around for decades, right? There's robots out there. And most of the time, for it to make economic sense to deploy a robot in your facility, you needed to have a process that was low mix and high volume, right? So you need the low mix because the robots weren't really very smart. They just did the exact same path over and over with extremely high precision. But you also needed the high volume because the robots cost a lot of money. There was a high upfront capital expense to install the equipment. And so you needed the volume to justify that. But based on these changes that are happening behind the scenes in the automation industry, it is shifting. And so tasks that were not economically feasible before to automate start to become economically feasible. And so you can start to think about processes that are high mix and low volume. So maybe it's different products coming down the line. Maybe you don't need jigs and fixtures to arrange the product so that it's in exactly the same position every time, so the robot can actually adjust to differences and adapt on the fly. And then because there's perhaps a lower upfront cost, you're using software to compensate for less precise hardware, then lower volume things start to make sense to automate. Okay, so you still have to be judicious about picking a project that makes sense to automate, right? Not everything is automatable right now today. I think if you think about Tesla trying to bring up their Model 3, ramp up their Model 3 production, right? Elon Musk almost bankrupted the company because he tried to automate everything and get rid of humans completely out of his facility. And we're just not there yet. It doesn't make economic sense to try to do that yet. So there's a few rules of thumb for when it does make sense to automate something. One is when you've streamlined your process so much that a human operator doesn't have to move their feet to accomplish the job, right? Everything's within arm's reach, and maybe they're doing slightly different motions depending on how things come down the line, but basically it's a very repetitive, tedious job. Then those types of things tend to be easier to automate. And the second thing is more of a human factor is when a job is really tedious or uncomfortable. So maybe there's fumes from a chemical or glue or something. Maybe there's high temperatures. So those types of things make sense to automate because it can be really hard to keep a human in that job, right? There's high turnover, and then you get less consistent results because it's hard to keep somebody trained and willing to do the work. And so that can be something where it makes more sense to automate. And then last thing is, if you are just starting an automation journey, you typically want to start with a small project and gain some confidence and momentum behind the process of bringing automation in. Actually, most manufacturers are still very manual in the US. There's a lot of room for things to still be automated out there. But if you decide to do that, you want to start with easy, small projects and get quick wins. Okay, so now you should have received, I had a worksheet that was passed around. And so this is, has anybody ever been to a leadership or management conference where they did the peanut butter and jelly exercise? You know what I'm talking about with that? Yeah. So basically, the point of this exercise is to teach managers and leaders how hard it is to transfer knowledge from one person to another. So we're not going to do this exercise, but it's a really good way to think about. So if you're not familiar, I'll just explain it. So basically, the idea is you write out all of the instructions for making a peanut butter and jelly sandwich for somebody who's never seen or done that before. And so you have to write in excruciating detail every single step of the process. And typically what happens is no matter how many words you use or how clear you've been writing it all out, there's always something that's up for interpretation that somebody can mess up. And so, for example, maybe you forgot to write that you have to untwist the twisty and take the bread out of the, front of the bread bag, right? And so then the person trying to follow your instructions just rips open the bag and then the bread spills all over the floor, something like that, right? So that's not what we're going to do today, but it is a good way to start to think about how to quantify the number of abstract concepts that would have to be taught to a robot in order for it to perform some task. And so the worksheet that you have sort of will walk through some steps of doing that. So if you could think about a bottleneck, some kind of thing that happens in your print shop or bookmaking facility, whatever it is, that has to be done manually by a human, and then write out the instructions for doing that job. And then the next step of the worksheet is to count the different parts of speech and quantify the amount of grammar that's needed to describe that task. And so typically things with a smaller grammar and fewer abstract concepts that have to be understood to complete the task are easier to automate. So I just wanted to take 3 to 5 minutes, just quickly write it down. I'm curious if anybody's willing to share afterward whatever they come up with, and I'll just stop talking for a few minutes so you can look at that. So if anyone gets to the end of this and is willing to share, I'd be curious to hear what you've come up with. So just raise your hand.
Okay, so I did pulling covers. And then Sarah here did the part before that. So pulling covers. So collect the box of books for specific title. Stack the books on table. Take one book at a time. Remove front cover. Remove back cover. Stack books on tray in order on conveyor loading to binder. You don't always have to take. So that would be an add-on. So like say, so sometimes glue is still sticky. So one of the things would be, but I don't think, I don't know how you get into a lot of
Right.
what if. So you take 1 page or 2 page, depending on where the copyright. That's why I stuck with the front and back.
Yeah, I mean, that's exactly right. There's all kinds of edge cases.
Yeah, yeah.
And capturing all of that edge cases to fully understand a concept is
Yeah.
most of the work of making these kinds of things work.
Yeah, I
Yeah.
didn't have enough paper here to go
Yeah,
through
right.
all.
Sure. Well, thank you for sharing. Yeah, I mean, this is just to hopefully get everybody's brains starting to think in terms of what it would take to create the AI models that would be needed to automate tasks. Because all of those abstract concepts, when you start to count the grammar, those have to be encoded into the model. And then you have to find a way to test the model to make sure it actually understands the concept in a general way, right? It's actually a lot like testing human beings in school, right? You have to come up with ways to check whether they understand, you know, the difference between color variations that matter and color variations that are important, whatever it is. Um, and so, yeah, this is just to get your wheels turning a little bit. If you wanted to start thinking about automating, this can be a good way to sort out your potential projects and figure out what's easier to automate versus what's maybe more difficult. So say you've gone through that process, like you're really excited now, you want to start an automation project. And uh, you've sorted through your different bottlenecks and you have some ideas. So what is the next step? So most companies don't have an in-house automation team. Well, I'm curious, does anybody here have on staff people who are just in charge of automation in their facility? Yeah, it's still pretty rare. Like I have seen some examples of that. But most of the time, you would need to hire an outside company. They're called a systems integrator, and they would come in and help you design a procedure to accomplish your process, right? And so there is an organization, it's called A3. It stands for Association for Advancing Automation. They do a conference every year. Usually it's in Chicago or Detroit. I think next year it's in Las Vegas. But they'll have a whole bunch of systems integrators there that you can meet with. And they also have, if you just go to their website, lists of systems integrators. So to help you get started on an automation journey. Um, but I just wanted to point out that not all systems integrators are created equal, right? And so just roughly dividing them into two kind of buckets. So on your left is a picture depicting, you know, a legacy systems integrator is a company that just does kind of bread and butter projects, things that are really easy to automate or have been automatable for a very long time. So like installing conveyor systems, right? Conveyor systems have been around since Henry Ford. That would be the kind of project that those systems integrators might take on. Palletization, scanning and tracking product as it moves through a facility, those kinds of things. And so they might have lower margins and be able to just quickly churn through those kinds of projects. On the right side is this is just depicting sort of the forefront of what's actually deployable in a manufacturing facility today. So this is exactly what I was talking about in terms of a high mix process, right? The parts are all jumbled together in a bin. There's multiple parts mixed together. And the robot is using computer vision to identify the different parts, identify the pose of the parts, and on the fly in real time, figuring out the path to move the arm to pick up that part and move it and sort it to a different place. So that is the type of robotics that is possible and is being deployed today. And you would typically want a more advanced systems integrator that's more comfortable integrating AI into their projects to do that kind of work. Advanced systems integrators would also have the capability to do more kinds of simulation. So creating digital twins of your facility and physics simulations of the process as you go through it. Um, and if you wanted to take a step further, so all of you would have to decide for your own company what makes the most sense, whether, and then, right. So what I've been talking about using the transformer neural networks, overarching term for that is physical AI. And so if you were interested in preparing yourself for the day, which is not today, but maybe in a year, when physical AI is more ubiquitous and being deployed in real facilities, like what would you have to do to prepare yourself for that day? And so the image here in this slide is giving an example. You need to start creating the data sets that would be used to train those transformer neural networks. So what do you need? You need an input data stream, typically a point of view video of what it looks like to complete whatever the task is that you're trying to automate. And then matched to that video input, you also need the pose of the manipulator moving through space in a world coordinate system. So that manipulator could be a human hand doing a task, or it could be a robot end effector. But the main point is that you need to know where that manipulator is at all times, 50 times per second, and match to the input video of what it looks like. So that's the data set that you use to train these kinds of models. And so the way that you would start to think about capturing that kind of data, and by the way, some of this stuff probably doesn't make sense for manufacturers to be implementing right now, but there are a ton of startup companies that would love to have access to the data that you have access to just natively by running a real world facility, right? Because there's this race to prove economic value by doing exactly what I'm talking about right now. And so one of the ways to collect that kind of data that I'm about is collection through teleoperation of a robot, right? And so you can strap up a human in a virtual reality headset and with equipment to monitor the human's motions as it goes, as they, perform a task. And they're essentially teleoperating the robot. So the robot's like a puppet and they're the puppeteer. And as the human demonstrates through the robot how to do that task, you're recording both the position of the robot's hands as well as all of the sensor data that's coming in through the robot's cameras. And so that's exactly the data set that you need to collect in order to train AI to do the task. What might be more feasible for manufacturers to start to think about, and that is lower cost to get going, is collection through simulation. So we have really, really good physics engines. They started out as the physics engines of video games, and now we can use them in robotics. NVIDIA is creating a whole ecosystem around this. And basically, they are software products that model the entire physical world. So if you drop light sources in, it actually models the rays of light moving through the world and creating shadows from objects. It also models the weight of objects and the compression of objects and how they move around and act in the physical world. And so they actually have really high fidelity with the real world. And we can create photorealistic views. Anywhere we drop a camera into that virtual world, we can see what it would actually look like pretty much in the real world, where you would actually have to do a double take to realize it was just an animation, right? And so you can also, so you can get that input data stream, the video stream that you need, and you can also get the position of the manipulator as it moves through space and does a task. And so you can start to train these AI models just by starting with synthetic data that's created in a virtual world. And this is a little bit of an aside, but I think it's really interesting that so much of this work is coming out of an artistic space, right? So NVIDIA based their robotics ecosystem on a file format that was invented by Pixar. It's called the Universal Scene Description file format. And actually, the best company in the world at doing exactly what I'm talking about, creating these virtual worlds, and then taking those models, implementing them in the real world and testing it and iterating back and forth, is actually Disney. And so this video is just showing their Disney's Stuntronics department. And this is where they actually create all of the graphic effects that are used in their superhero movie. They do exactly what I'm talking about. They create a virtual world, they create motions in the virtual world, they build physical manifestations of robots that are actually do those movements, and then they record all of this to put it into movies. And so I think it's interesting because it's really well, really because I think a lot about for my own kids, like what are the jobs of tomorrow going to be for these guys? Like I have no idea, but I think one of the jobs of tomorrow is having the skill to use both your right brain, sort of the artistic eye that it takes to view the world and then recreate reality in a virtual setting. So that's a very right brain kind of skill, but also it's a technical job, right? You have to understand computer programming. You have to understand that this is eventually going to be used for training AI models. And so there's this left brain component. So finding people with both of those talents at the same time is pretty rare, and I think will be very useful going into the future. But the main takeaway from all of this is that we're moving out of this paradigm where before we had to program robots to do very uniform movements. And so we did the low mix kinds of things could be automated. And it was very tedious. You had to explain every step by step, and program every step into the robot so it would know what to do. And now we're moving into a paradigm where we're actually teaching robots to do things. And so, the exercise that you guys just went through, it really gets your mind thinking along those lines. Is now we need to demonstrate to the robots how to do tasks. We need to find ways to collect the data to do that. Okay. So, but even as good as AI is getting, I want to make the point that there, at least in the foreseeable future, there will always be a need for a human in the loop in all of these systems. Because even if the AI does the right thing 99% of the time, or 99.99% of the time, whatever it is for your specification of what's needed, and the AI achieves it, there will always be those edge cases that we talked about, right? And you think about Waymo, and the journey of creating a self-driving car, that's a kind of general purpose robot, I would argue. And they spent probably the first year mostly getting the car to work most of the time. But it was all the edge cases that took them another 9 years before they could actually get to a commercializable product. And it's taking, another 5 years to start to move beyond the Phoenix area into other cities. So edge cases are really key you want to be able to capture those edge cases and then feed them back into the model and retrain and update the model over time. And so that only happens if you have a human in the loop that can intervene. And the other benefit of having a human in the loop is that when an intervention is necessary, you've thought through the process of what it looks like when things go wrong. And so you minimize any disruption to your production. And so this will be important long into the future, even as we get more and more AI integrated with automation. And so that's kind of a little bit about how to start an automation project. And I just want to, in that section on, this is a little bit of a nightmare horror story, right? So I have walked through multiple manufacturing facilities where they spent a lot of money. They put in robotic work cells, and those robots are sitting there mothballed, not doing anything at all, right? So like, can you imagine being the manager who was in charge of bringing in that project, and then the whole thing just stopped being used because there lots of things can change. Maybe the person who really knew the most about running that work cell left. Maybe your process changed just enough to where it didn't make sense to keep using the robot, and it was too hard to repurpose the robot to do something in your new workflow, right? And so the worst case of that I saw was a huge welding shop. And they had hundreds of welders on staff. They did big structural steel, like building bridges and that kind of thing. And they had this enormous KUKA arm just sitting there, just completely covered in dust. It's on a big gantry. And the systems integrator that they had picked to install this was out in Israel. They came, they did the installation. It worked great for a few months. And then eventually their process changed enough, and it was too hard to keep the integrator, helping them make those changes to keep the robot useful for how the workflow was changing. And so it was just easier to have the humans do it. And they ended up with this multi-hundreds of thousands of dollars of capital expense just sitting there. We looked into trying to upgrade it for them, but the way the business models work for these robotic arms companies, at least historically, has been that they want to sell new robots. And so this robot arm was still running on like Windows XP or something like that. And it was completely outdated. And they just told us, well, you'd have to replace the whole thing. Even though the arm itself, there was nothing wrong with it. It was just the computer. And so that is a situation that we all want to avoid because there's no point in installing automation if there's not a return on investment. And so I want to talk a little bit about how to finish an automation project. And so if you go through the process of designing this, work cell and you have it installed in your facility, is the project really finished? Kind of, but also no, it is not finished. You need to have an ongoing relationship and have built up trust with that outside systems integrator that you've brought in. So typically, the systems integrators should have planned from the beginning, and this should be in the contract, where they will continue to provide some kind of service level agreement, right? So response times when things go wrong and how they will, help make sure that your facility is, minimize impact of anything going wrong. And also how to provide training and support to your workers over time, as you have staff turnover and everything. And also the workforce development of taking your existing staff and training them on the new process and how to, create value, higher levels of value in the more automated workflow. Because, ultimately for US labor to be competitive with the rest of the world, they have to be more productive. And the only way to achieve that really is to bring in more and more types of automation. So we need our workers to be contributing higher level tasks. And that actually is good for them too, because the jobs will be less tedious and boring and safer. But they will have to be educated to be able to do that. Let me check the time. I think maybe, so this is the other side of your worksheet. I don't want to use up too much time on it. I'm getting closer to the end of my little window here. But basically, when you start a project, you should also have planned out how you're going to measure the success of that project. And so I would be curious, maybe we can just like show of hands, like maybe somebody could shout out what are the sort of key performance indicators that are important in your industry. So I know a little bit less about bookmaking than some other areas. And so I'm curious, what are the metrics that are really important that you would want to see improved by bringing in automation? Any thoughts on time delivery?
Time delivery, yeah.
So there's a throughput piece of that, right? Just like reacting to an order coming in and then how fast can you turn it around? Yeah. Okay. Anything else? I mean, the point, go ahead. Hmm? Right.
Lowering costs, yeah.
So, I mean, costs can really come from all kinds of different sources, right? There could be, the labor costs or the materials costs. And so trying to figure out which of those specifically you're trying to impact by bringing in automation would be important to think about up front. But the key takeaway is just, you need to think about what are your metrics that you're trying to improve and then figure out how you're going to make sure that that happens when you're done with your project. Okay. And so now I want to, if you'll indulge me a little bit, to go back to the big picture perspective a little bit. There are a couple of things that I see changing over the next few, 1 to 5 years in the automation industry. And one of them is a shift to more in-house automation talent, in-house automation teams. So I have seen examples of companies that have done this really well. It can be kind of a hybrid model where you have robotics engineers on staff. They're in charge of getting to be really familiar with your production process and estimating ROIs before you start a project. Uh, and then they can prototype a work cell and then hand that off to an outside systems integrator to actually build and implement in your facility. But they would just be people who are in charge of tracking automation and making sure it's having the impact that is desired. And the advantage there is that then you don't have the expertise walking out the door as soon as the project's over, right? When you hire an outside systems integrator, it's kind of an intimate relationship with an outside company. You need a strong level of trust to know that they're going to be there when you have problems down the road. And so this is one trend that I think will happen more and more, especially as automation talent supply catches up, more and more people trained in this kind of technology to what I expect will be growing demand in the US. And then the other trend, if crystal ball kind of trend, is I expect that automation projects will shift from more of a capital expense up front with really high cost, expensive components to more OpEx costs ongoing. And the reason for that is, what I've talked about already. We can use software to compensate for lower quality hardware. But then with less precise hardware, it may have a shorter lifetime. So there's more planning involved in logistics and making sure that there's spares on hand, proactive maintenance and swaps happening to make sure that there's no impact on your production. So that's where that sort of balance will shift. And the other thing that I think, and this is more for the robot arms companies, right? They really wanted to lock people into their own brand with their own proprietary software stacks and force people to have to replace robot arms on a periodic basis. And that worked when it was for really high volume, like car manufacturing or whatever it was, where that capital expense could be justified. But I think that as we want to automate more and more of the lower volume tasks, then it will be even more important to be using components that are open and that can be redeployed easily. And so your work cells aren't getting locked into only doing one specific task. And so those kinds of products are also coming on the market. There's new ARM manufacturers. Typically, they start out selling into research facilities like universities and that sort of thing. But then they all want to make the leap and become reliable enough to be trusted in manufacturing environments. But they use open source, like there's something called the Robot Operating System, ROS. So they have interfaces with that allows you to program from a very low level all the things that the robot can do without being locked into some vendor's proprietary stack. So those are a couple of trends that I see. I really appreciate the invitation to come out and talk to you guys. I hope some of it you might have found interesting. Feel free that on the left, you can connect with me on LinkedIn. If you are interested more in defect detection and using AI for computer vision to do defect detection, you can check out our website on the right. And yeah, I'll be around afterward if you want to talk. And if you have any questions, let me know. Yeah.
As far as in the print industry, the number one question I get as a manufacturer is, we want automation. I mean, we want to increase productivity with no further employees. But where you're seeing this, is this to replace skilled labor more accurate? I mean, because it's hard to cost justify replacing a very low wage employee, right? Isn't it easier to ROI a high wage employee?
Yeah, typically, rule of thumb is that you need to get ROI within 18 months. So if you're taking over the job that you paid somebody $60,000 a year to do that job, then you can spend maybe $90,000 on an automation project. And with the traditional arms manufacturer, like robot arms manufacturers, that $90,000 doesn't really take you very far. And so that's where you have to start to be able to believe that the software can compensate for a less expensive arm, but you can still achieve the same result. And so that's something that is, we're in a transition, an inflection point in the industry, but that's where I see it going. Yeah. I hope that answers your question.
Well, fortunately, we're still at a tough part where labor is not coming, right? I mean, we're down in terms of people retiring, not enough folks in the workforce. We're at the last few years, the death rate's higher than the birth rate. There's not going to be people to do those jobs, even if they're low paying, they're just not
Right.
there.
Yeah, I think that's what I hear most of the time is that that there's a labor shortage, especially in the US. And so it's really not job replacement, right? We have to keep the labor we have, but we need to augment them to increase productivity.
I want to follow up on a comment you made around digital twins.
Yeah.
And wondering what you see as a benefit or where you see the benefit of having a digital twin, say in a book manufacturing environment or in a different physical manufacturing environment.
Right. So digital twins, I mean, that term can be used loosely and to mean some different things. One of the things that can be really great with a digital twin is understanding and optimizing product moving through your factory, right? So really understand, it's kind of like a queuing theory kind of mathematical problem of how long does something have to take to get through this station before, it can move to the next station, and when will that station be available? So all of that kind of stuff can be modeled in a digital twin. And then some of the things that I also talked about were those actually moving through a process and doing a task in in a virtual world that mimics reality. And so that can be termed a digital twin as well. And so I think the main takeaway is that doing things in software is always going to be easier than putting steel in the ground, buying real physical hardware. And so you want to iterate as much as you can in software land before you then, try it. You never get away from having to try things in reality. You still have to go through that step because there's going to be things in your digital twin that don't capture reality, right? That are missing. But it will help you get a lot further along the way before you start spending the money to buy physical hardware.
Thank you, Joe. Really appreciate it.
Yeah, thank you.